Everyone, welcome to Module 1.4b, the brain and its structures. Here's the vocab, pause if you need to. Okay, so we are going to start with the three main divisions of the brain. And within each, there's going to be more parts. There's going to be a lot of parts of the brain in this video, actually. And so when I give you, like I say, this is the one key word, or this is the two words, you want to boil down these vocab words in the brain to like one function if you can, or like two words if need be. Okay, and also I'm going to give you mnemonics like hand gestures. Please follow along and do these because research shows that these little stories, these little hand mnemonics, they really help solidify the information in your brain. And when there's a lot of vocab for the different parts of the brain, it's going to make a difference. So first, go like this. This is your hindbrain. This is your spinal cord, and this is your hindbrain. The hindbrain, the key word is survival. There are going to be important functions in these parts of the brain that are important for survival. In terms of the shape of the brain, this is the innermost region of the brain. So it is the oldest, most basic, primitive part of us. Next, go like this. This is the transmitter. This midbrain transmits the information from the spinal cord brainstem, hindbrain area, to the midbrain, and then from there, it takes that information and sends it to the forebrain. It determines where does that information go. What part of the forebrain does it go to? The last part you would need a partner for, so we'll do this in class. But if one person was going like this, imagine that the other person is making a cerebral cortex over top. This is the forebrain. This consists of the cerebral cortex, the thalamus, the hypothalamus, and it manages complex activities, sensory associations, and voluntary motor movements. Okay, so within the hindbrain, and this includes some of the forebrain as well, because it's got the thalamus here on the top of the brainstem. But when we think brainstem, we want to think survival. So the brainstem has the medulla and the pons. Again, if you were to Google like different parts of the brain, you might find like a neuroscientist like definition or like an 8th year med student definition. You don't need those definitions. You want to stick to the key word I'm giving you. So the brainstem is all of this here, okay? And it's part of the hindbrain, and then some of it is the forebrain, and it is going to keep us alive, meaning if the brainstem was done, you are not going to survive. The medulla is on the brainstem, and that is important for breathing and heartbeat. Those are your two words. Pons is important for coordinating movements and controlling sleep. Thad the mailman, the thalamus. So my little memory trick is Thad the mailman for thalamus. He is going to deliver all sensory information except for smell. It's going to take whatever it is, touch, hearing, vision, and it's going to send it out to whatever part of the brain it needs to go to. So Thad the mailman delivers all mail, but I'd like you to picture him without a nose. He just has like a hollow hole here where he should have a nose because he does not deliver smells. And Thad the mailman sits on top of the brainstem. It's part of the forebrain. Also in the brainstem is the reticular formation. This is going to filter information like even while we are unconscious. This is kind of like the little like soldier on guard, so that if we need to like wake while we're sleeping because there's a fire or something, like this is the thing that is going to wake us up. If your reticular formation is damaged, you would not be unable to wake up from a coma. You'd be in that unconscious state and you'd be unable to gain consciousness. The cerebellum is in the back of the brain, so sometimes called the little brain. It looks like a little brain. And this, you want to think balance and coordination. Those are your keywords, balance and coordination. And in terms of balance and coordination, what it's really helping you with is procedural memory. So this is, if you're an athlete, think of all of the moves that you might do when you're swinging the bat or doing a particular dance move, or you're playing soccer. Your body is able to move in that way, and you don't need to like consciously really focus in on like, oh, I have to do this to my foot if I want to make the soccer ball go in that corner. Like, you're just able to do it, right? Like, if you know how to ride a bike, you're just able to do it. That's the cerebellum. So it's balance and coordination, but in related to these like skills, memory, movements, okay? The limbic system is associated with emotions, drives, and memory. It's located mostly in the forebrain below the cerebral hemisphere. So it's going to handle our emotions and the ones that are important to survival, like fear and aggression. And it's going to also handle our drives. There are 5 parts to the limbic system that I'm about to go through. So each of these will have their own slide for me to discuss. So the first part of the limbic system is the amygdala. So you want to think aggression and fear. If you were to stimulate the amygdala, there would be an increase in aggression and fear. If you were to lesion the amygdala, then there would be a very subdued animal. There would be a lack of fear, a lack of aggression, a very docile animal. Hypothalamus. This one controls a lot, so stick with me. The textbooks, all the intro psych textbooks have this same mnemonic. It's a well-known mnemonic for how to remember the functions of the hypothalamus. It's called the 4 Fs. However, in my class, we have added a 5th one because it has a 5th function and it's just easier to remember if we make it into an F. So as you'll see here from this screenshot of a textbook, the 4 Fs are fighting, feeding, fleeing, and mating. And our 5th one is furnace, which is not written down here because we came up with it. So add that one in. Fighting, feeding, fleeing, mating, and furnace. So what does that really mean? Because those are just mnemonic ways. And you're like, what does that mean? So fighting and fleeing, this is our fight or flight. We got hunger, we've got thirst, we have sexual behavior, and we have body temperature. So why is it called hypothalamus? Not just to make your life more difficult, which it does, right? There's the thalamus, Thad the mailman, hypothalamus, 5 Fs. It's hypo because it's below the thalamus. And it's linked to, this is very important to our emotional drives and our reward system. We're going to talk more about that in a second. So when you think about the limbic system, it has something called the reward pathway. We talked about dopamine in a different mod. Dopamine is that pleasure reward neurotransmitter. Remember, it's not about happiness. It's the do it again button. 2 neuropsychs accidentally found this region of the brain when they stimulated the hypothalamus, this particular part, and they were these rats who were able to just press a button and release dopamine. They pushed that button until they physically collapsed. They forgoed food, water, everything, sleep, until they physically could not push the button anymore. So again, it's showing you that like addictive aspect, that pleasure reward, do it again. Really do it again. So depending on how addicting something is, so think of different drugs, people will keep pushing that button. It's not happiness that it's bringing them. It's pleasure and reward. Do that again. And an important part of this pathway is the nucleus accumbens, which is a key part of this reward center. It's located in the front of the hypothalamus. So the hippocampus, we want to think, we're still in the limbic system. We want to think new memories. So for this one, we have a hippo on campus and he is making new memories. It is his first day on campus and he's taking pictures. He's making new memories. Hippocampus is responsible for those new explicit memories. It is not where all memory information is stored. There is no specific location where all memory is stored. So if you have a damaged hippocampus, you would be unable to make new memories. You would go through your day and it just wouldn't like save. Think of like it as the save button to some of those important events. The cerebral cortex. So now we're in that forebrain part. The cerebral cortex is that interconnected neural cells that cover the two hemispheres. This is our ultimate information processing center. This is where all of that integration happens between like motor movements and planning ahead and decision making and hearing, and all of it comes together and is happening here in the cerebral cortex. Our conscious awareness is happening here in the cerebral cortex. So if we were to take the cerebral cortex and break it down into 4 lobes, which we have, this is what we would get. And I have a little hand mnemonic for each. So the frontal lobe, you want to go like this because it is thinking, planning, judgment, decision making. Okay. So if you're like making a decision or thinking or planning ahead, you might go like this, because this is where our frontal lobe is located. Next, you go like this to wash your hair, because the parietal lobe is located right here. And this is touch and body position, which is something that you would do when you're washing your hair. Occipital lobe, you want to go like this. And if you bump the back of your head, you might see stars like the cartoon characters. That is because the back of our head is the occipital lobe, and that is responsible for processing visual information. The last one, you can go like this, and this is the temporal lobe, and you want to think hearing, headphones, or the word tempo if that helps you, because this is auditory processing in the temporal lobe. Okay, so the motor cortex controls voluntary movement. That's the key word, voluntary movement. It is located in the frontal lobe, so that planning, judgment, decision-making area, but it's towards the back, so it's right next to the parietal lobe, and it's actually specifically right near the sensory cortex, which I'll talk about more in a second. But we can actually use this part of the brain, the motor cortex and the sensory cortex, and we can actually make cognitive neural prosthetics, meaning that we can connect that part of the brain that like controls your left arm. And if you have lost your left arm, we can connect that part so that you just think about moving your hand a certain way to type, to play a video game, to walk if it's a leg, and the prosthetic will function and react just like your limb did before. It's very amazing technology. So what is that sensory cortex area? So the somatosensory cortex, which is right next to that motor cortex, but in the parietal lobe, the motor cortex is in the frontal lobe. This is going to help us process body touch and movement sensation. Does this sound a lot like the definition I gave you for parietal lobe in general? Yes, but obviously there's a lot more in the parietal lobe. Remember, I'm giving you the Psych 101 definitions. This is specific to this area. So let me show you this little diagram. This is the somatosensory cortex. Do you see how much of the somatosensory cortex is just devoted to your hand, each finger, and your face, your tongue? It has a lot of brain connected to it. That is because these areas, we need more fine motor skills. We need more intense like sensation reaction in order to help us survive. These have been essential. Down here, right, you might hurt yourself down at your leg, and that might hurt a lot less than if you were to hurt your tongue or your lips or your hands. And there's just less sensation there. And this is just homunculus. He's also showing you how much of our brain is devoted to each part. So like his mouth and his lips and his ears are a lot bigger. His hands are a lot bigger than this like lower half of his body. The prefrontal cortex. So that is the front of the frontal lobe, and that specifically is judgment and planning. So if there was damage to this area, you might have someone who still exhibits same behaviors, except their personality is slightly changed. They might be unable to plan ahead or unable to do some of these executive functioning skills that they were before able to do. Okay, 2 areas devoted to speaking. These are Broca's area. So for Broca's area, this is on the left side of the brain, and it's responsible for speaking. It's the reason we can speak words. For this, I want you to think of a talking doll. And imagine the talking doll is, you know, one of those little, hey mama, mama dolls, and you just snap its neck. Okay? Why am I giving you this bizarre imaginary situation? Because I want you to remember broken doll. When you snap that talking doll's neck, it can no longer speak. Broken doll, Broca's area. Next is Wernicke's area. This is responsible for understanding language. So in this case, a person might be able to speak words, but the words aren't, if a patient can talk, but the words aren't making sense, right? They might have Broca's aphasia. But if the patient can understand language, cannot understand language, but can speak it, then they might have Wernicke's damage. So these are different issues that can occur. Just remember Wernicke's, understanding language, Broca's, broken doll, speaking. So these are parts of what we know as association areas. These are parts within the cerebral cortex. They're not involved with they're not like your motor cortex that have a specific function. They are the integrators. They integrate all of the information. They're the higher mental functioning. They're taking the auditory, the visual, the planning ahead, the memory store. They're using everything to apply to those higher cognitive thinkings. We know that Einstein, even though he had an average size brain, he had more of his brain devoted to parietal lobe and specifically like enabling mathematical and spatial reasoning. And that is correlated to his association areas in that part of the brain. We also know that when brain surgeons stimulate a certain part of the association area near the motor cortex, people moved, but they didn't even know that they were moving. So they're involved in certain things they're involved in things in a different way, but still related to other parts of the brain. Again, association areas in more detail would be beyond a Psych 101. This is just what you need to know, that they're the integrators. They are the functional connectivity. They're integrating and they're making the different parts of the brain work together during these various tasks. Okay, Phineas Gage is a good case study of how we learned that different parts of the brain control different things. In 1848, he was a railroad worker who got a railroad rod shot through his head, came out the other side, flew out, and he lost a teacup amount of brain. Yet he lived for many decades to come. He did not die from this situation. And he was no longer Gage, is what his friends would say, is that his personality that was, able to kind of like be more of a leader, be more congenial. He became a little more, his personality changed. He wasn't himself anymore. So they realized that front part of his brain, which is what he lost, is important and related to our judgment, our decision making, and our personality. This is a case study example of why we can't, replicate this. Okay, so takeaways. Remember the different parts of the brain. Remember brainstem, think survival. Limbic system, think emotions and drives and memories. Hippocampus, hypothalamus. Remember the 5 Fs. Remember the cerebral cortex. You can divide it up into those 4 lobes. Remember what those things are. Remember motor cortex, voluntary movement, cerebellum, balance coordination. That's like procedural memories, like riding a bike. Prefrontal decision, judgment making, association areas. That's higher level thinking, connectivity. Phineas and his chunk of brain. Broca, think broken doll. And we will talk more about all of this in class. Thanks, guys.